Now let's look at a few more example problems. They all fall into this category of 2D quadrant problems. So this one is called stars at the Timos online judge. So we are given n stars, each have a position represented by xy on a plane, and the level of a star is the number of stars that are not higher and not to the right of a given star. So basically, the same x coordinate and to the left, and the same y coordinate were down. So essentially, this is the third quadrant. So given the point, we want to know how many other points are in the third quadrant. So that's pretty much it. So uh, using the analysis we have earlier, there are two dimensions. We use one dimension as index in the segment tree, and then we sort on the other dimension and add point into it. Um, so for example, we can process star based on the x ordering, and for each star s, the prefix sum based on the y index. So the prefix sum is essentially the range sum from the beginning to that point. It's the level of the star. Then we compute that, and then we add one to the position. So so this is pretty much it. And for this problem, you can easily switch x and y. So you can pick one of them to be indexed and then sort on the other. So whichever way you pick, it would work. So this is a problem from user code. There are n cows with distinct height, and the height can be fairly large, and they stand on one line. And we say a cow is unbalanced if the Li and Ri differ by more than a factor of 2, and Li and Ri are the number of cows taller than it on the left, and Ri is the number of cows taller on it on the right. So we want to compute the number of unbalanced cows. So basically, for each cow, we can check whether it's balanced or not if we can compute this Li and Ri efficiently. So then Li is essentially the left quadrant and the left side, and we want the taller one. So taller end. So then this will be the second quadrant, right? So the x is less than 0 if the current point is the origin point, y is greater than 0. And once we figure out one of these Li, then once we figure out Li, we can compute Ri, because we can easily compute by sorting the cows. We know how many cows are in total are taller than this. So if total there are 5, if 2 on the left, then the other 3 must be on the right. So it's also a 2D quadrant problem. And in this case, because the height value is sparse, so it's easier to sort based on that, and then create the segment tree using the indices. If we want to do it the other way around, we have to add an extra step by sorting the index and then map its index into its position. So it's doable. It's just a little bit more complicated. So yeah, so that's pretty much it for this problem. So here's another example. It's from Spot Online Judge. It's called It Is a Murder. So the detective walks up a stair, and there's a number written on every stair. He decides that for each number on the stair, he wants to know the sum of all the numbers that he have already seen. So that would be written on the lower stair, and which are smaller than the present number. And he wants to know the sum. So again, every point have two values: the value, and the position. So we want to know position-wise, it's less than this. So assuming we are we number the stair from bottom up from small to large. So position-wise is left, and also value wise is less. So I guess that's that's a third quadrant. And here slightly different from the previous problem. Instead of counting how many things are in there, we want the sum. But we can easily do that in SegTree by computing the sum. So basically, we just put in the value into the SegTree instead of just a 1 or 0 indicator. So that's pretty much it. Yeah, given the two orders. Yeah, so I guess yeah, there are need to deal with the case that the numbers are not distinct. Anyway, so that's a minor thing to deal with. And there are some similar problems. So I find two from LeetCode. So I didn't look at all the LeetCode problems that are tagged with segment tree. Look at maybe about half of them, and these two are fairly similar. Some of the problem tagged with segment tree are actually not the natural solution. The best solution are not to use a segment tree. It can be solved with segment tree, but oftentimes it can be solved without using it. So these two I think are similar to the problem that we've seen here.